The ether drag force is the force suffered by a material body that has a non-zero speed relative to the reference frame that can be associated to the local ether at rest. By reference frame associated to the ether at rest is understood the local reference frame in which the mean velocity of the etherinos is zero. Notice that since both the velocities of the etherinos and their mean value are vectors in 3 dimensions, the fact that their mean velocity is zero is compatible with the fact that the etherinos have, on the average, very high speeds. An analogy could be that of the air at rest, that is without wind, in spite that its molecules move very fast in all directions. When referring to a distribution of etherinos speeds in a given reference frame, for example that of the ether at rest, it must be understood that we are talking about a local reference frame associated with the etherinos of a limited region of space during a limited time interval, because in other far regions of space or in other epochs it can happen that the etherinos have a different global movement such that their ether at rest reference frame might not be the same as the former one. This animation shows a particle suffering an ether wind coming from the right. It can equivalently be said that the particle moves relative to the ether, and due to it suffers the force that has been called ether drag force. And this other animation shows a material body composed of several elementary particles moving relative to the reference frame in which the ether can be considered at rest. Once again, due to its speed relative to the ether, the composite body suffers a force in the opposite semi-direction to that of its velocity relative to the ether. The ether drag force suffered by a body that moves through the ether is, like all forces given by the net etherical impulse suffered by the body in unit time. Such net impulse is the vector sum of the etherical impulses suffered in unit time by the elementary particles that compose the body. When doing the calculus, it is found that the ether drag force on a single elementary particle is directly proportional to the cross-section of the particle to collisions by the etherinos, and to the velocity u of the particle relative to the ether. The semi-direction of the drag force is the opposite to that of the velocity of the particle. The constant of proportionality that is here called k sub d1 depends only on the speed distribution of the etherinos in an ether at rest. A cross-section can be visualized as the surface that a particle presents to a flow of etherinos that reaches it by a given direction. The expression number 1 is an approximation valid for speeds u of the particle significantly smaller than the average speed of the etherinos. The ether drag force on a composite particle made of many elementary particles is given by an expression similar to the former, but where now the cross-section sigma assignable to the composite particle is the sum of the cross-sections of the elementary particles that make the composite particle. The calculations show that the constant k sub d1 appearing in expressions 1 and 2 is proportional to the number n sub 0 of etherinos in unit volume of the ether, and inversely proportional to the fifth power of the mean speed of the etherinos. The model considers that the inertial mass m of a material body is proportional to the net cross-section sigma that the particles composing the body present to the etherinos. That supposition is consistent with the model, since the acceleration acquired by the body bound by internal forces is the mean acceleration of its component particles, and therefore Newton's second law will also hold for the body as a whole. The ether drag force on a body of mass m is then proportional to the mass of the body and to its velocity relative to the ether. Every material body free from other forces, subject only to the ether drag force, decreases its speed according to the same law. In fact, unifying some constants, the ether drag force on a body can be written as in the expression 3b. And applying Newton's second law to that force, the simple differential equation number 4 is obtained, whose solution shown in expression number 5 does not depend on the mass m of the body. This solution is an exponential function of negative exponent that indicates that the particle slows down in a continuous but gradually smaller way. In the expression number 5, u sub 0 is the initial speed of the particle at the epoch t equals 0. The time tau that the body takes to reduce its speed to half its initial value can be obtained solving for tau in the equation number 6, and turns out to be inversely proportional to the constant k that depends on the speed distribution of the ether, and does not depend on the initial speed u sub 0 of the body. Such time interval tau will be very big if the constant k is very small. But since k is inversely proportional to the fifth power of the mean speed of the etherinos, then the time tau will be very big if the main speed of the etherinos is very big, much bigger than the speed of light. In the majority of cases, the material bodies are subject not only to the ether drag forces, but also to material forces that have their origin in other bodies. In most cases, these material forces are much stronger than the ether drag force, and its influence in the movement of the bodies is greater. The ether drag force is not incompatible with the existence of stable or quasi-stable orbits when a body is subject to a strong attraction force by another body, because in these cases of orbitations, the ether drag force on the orbiting body is partially or totally counteracted by a component of the attraction force that acts along the same semi-direction to that of the velocity of the orbiting body, and hence in the opposite semi-direction to that of the ether drag force. This component of the attraction force that tends to increase the orbital speed of the body will be called the forward force. But it happens that the vast majority of the material bodies of the universe are in a smaller or bigger scale orbiting other bodies due to attraction forces, and therefore are subject to forward forces that to a large degree counteract the ether drag forces. For example, the atomic electrons orbit their nuclei due to electric attraction forces. The atoms gather together forming planets that orbit their stars due to the gravitation attraction forces of this. The stars orbit around the centers of their galaxies, again due to gravitation attraction forces. The galaxies orbit around in the galactic clusters, etc. This picture shows a body A at rest and the body B moving perpendicularly to the straight line AB that joins both bodies. The body A exerts a repulsion force on B. The body B has in the reference frame of A velocity u. It is also shown an etheriino coming from A hitting the body B. The velocity v sub A of the etheriino in the reference frame of A has been drawn in red. The velocity v sub B of that etheriino relative to B has been drawn in blue. The collision with the etheriino exerts on B an impulse along the semi-direction of v sub B, that together with similar etherinos that emerge from A in excess, contributes to the force F suffered by B along such semi-direction of v sub B. Velocity increments, and therefore also etherinical impulses and forces, are vectors that have the same modulus and direction in all the reference frames. The force F has a component F sub u along the direction of the velocity u, in this case along the opposite semi-direction to that of u, that tends to slow down the speed u that the particle B has in the reference frame of A. Suppose now, as seen in this other picture, that the body B is orbiting the body A due to an attraction force that A exerts on B. But an attraction force implies that the body B receives a deficit of etherinos from the zone occupied by A, in comparison with the etherinos that it receives from other directions. That would be so because A creates a redistribution of the etherinos that it receives from all directions in such a way that it decreases the amount of those etherinos able to give impulse to the body B. As seen in the reference frame of B, now the absence of an etherino of velocity v sub B, like the one drawn in the blue dashed arrow, compared with the balanced quantity of etherinos that it receives from the other directions, has the same effect as if B receives an extra impulse from an etherino of velocity minus v sub B, that is, along the opposite semi-direction. This excess etherino of velocity minus v sub B, together with similar others, now makes the force F suffered by B have the semi-direction of minus v sub B. This force F has now a component F sub u along the same semi-direction of the velocity u of the body B, and therefore tends to increase its speed. This force F sub u along the velocity of the orbiting body that tends to increase its speed is the so-called forward force. The forward force occurs in all the scenarios in which a body suffers an attraction force by another body: electrons orbiting nuclei, planets orbiting stars, etc. It can be seen that the forward force F sub u is proportional to the central force F and to the transversal speed u of the target body. But on the other hand, it was shown that the ether drag force on a given body B only depends on the velocity u of the body relative to the ether. That suggests that the conditions of full stability of a circular orbit are only strictly fulfilled for a specific orbital radius. Floating reference systems. Suppose a material body R with mass floating in space. This floating condition must be understood as meaning that the body is subject to 1. The gravitation force from all the rest of the bodies of the universe, mainly from those nearer bodies that exert on it a stronger gravitation force, and 2. To the ether drag force due to its movement through its local ether. But it will be supposed that the body is otherwise free of all external forces, like for example electric or magnetic forces, radiation, collisions with cosmic particles, etc. Suppose next a small enclosure or region of space centered at the body R that follows the body in its floating movement through space. Suppose that the body R that has only been invoked to define the floating reference system associated to the enclosure is now removed from it. It must also be supposed that the enclosure is small enough so that all its parts suffer the same gravitation field from the exterior bodies of the universe, and supposed that the reference frame associated to the enclosure does not rotate, or more precisely that its rotation is negligible relative to the rectilinear reference frames, that are those frames in which all the etherinos move in straight lines at constant speed. This negligible rotation can be certified if during the experiments the distant celestial bodies do not change noticeably their directions relative to the floating enclosure. With those spatial and temporal validity limitations, it will be said that the floating enclosure or region defines a floating reference system. It can then be asserted that any other small body B with mass placed inside the region and at rest relative to its imaginary walls will remain at rest relative to the region. The reason is that the only forces acting on the body B are the gravitation force due to the rest of the bodies of the universe and the ether drag force due to its velocity relative to the local reference frame in which the ether can be considered at rest. And both forces are directly proportional to the mass of the body, and hence B will suffer the same acceleration A relative to the ether and to any rectilinear frame than the acceleration suffered by the body R that was invoked to define the floating reference system. But if another body A with mass is placed inside the enclosure with an initial velocity v sub Ra relative to it, this other body A will have in general a different velocity relative to the ether and will suffer a different drag force to that suffered by a body at rest in the enclosure. Consider then what happens from the point of view of the reference frame S associated to the ether at rest. Let v sub r be the velocity of the region relative to S. Therefore, a body R at rest in the region will suffer the ether drag force shown in the equation number 1, where m sub r is the mass of R. The body A will instead suffer the ether drag force shown in equation 2, where m sub A is the mass of A. The gravitation forces due to the outside bodies of the universe suffered respectively by R and A are the product of their masses by a vector g that is the same for both bodies, since according to Newton's gravitation law, it only depends on the distribution of masses of the rest of the bodies of the universe observed in the small region. Due to these forces, ether drag and gravitation, the acceleration relative to S of the bodies R and A are respectively given in the equations 3 and 4. And therefore, in the Galilean framework with absolute time chosen by the model for its description, the acceleration of A relative now to the floating reference frame associated with R is given in equation 5. That is the same ether drag acceleration that would suffer the body A if the floating reference frame was that of the ether at rest. In other words, a body A with mass with any given speed u relative to a floating reference system behaves relative to that floating frame in the same way as it would behave if u was its speed relative to the reference frame of the ether at rest. It would later be also shown that the force that the body P exerts on a body Q only depends on the velocity of Q relative to P and does not depend on the absolute velocities of these bodies. It can therefore be expected that the laws of mechanics are the same in any floating reference system and equal to the laws of mechanics that hold in the ether at rest reference frame. This equivalence between floating reference frames is similar to the equivalence between inertial frames of mainstream physics.